The new section is entitled Transitive and Substitution Properties. What this basically says is the following. If you have three angles and you come to know that angle 1 and angles 3 are congruent, and also angle 2 and angle 3 are congruent. Well, angle 1 and angle 3 have the same measurement, and angle 2 and angle 3 have the same measurement. For argument's sake, say angle 2 is 40 degrees. I meant to say angle 3 is 40 degrees. But 1 and 3 are the same. 1 and 3 are the same. Therefore, angle 1 is 40 degrees. Angle 2 and 3 are the same. Therefore, angle 2 is 40 degrees. What do you know? 1 and 2 are the same. So that's what you want to prove. Prove that angle 1 and angle 2 are in fact congruent. This is basically just a transitive law. 1. The givens, this. The reason? It was given. Now, if two quantities equals a third quantity, those two quantities are equal. That's the transitive property. Angle 1 is congruent to angle 2. Since it's angles, I'll say angles. If two angles are congruent to a, let me actually write the number 2 and 3. If two angles are congruent to a third angle, then the two angles themselves are congruent. If two quantities, if you and your friend both have the same amount of money in the bank, say as your teacher, well then you and your friend also have the same amount of money as one another. Whether it's money in the bank, the measurement of an angle, the length of a side of a triangle, the transitive law follows. That reason that I just gave, that's the transitive property. A, B, and C. Lengths A, B, and C. If you are given that line segment A is congruent to line segment B, and line segment A is also congruent to line segment C, that is, both of these line segments are congruent to A, you're being asked to prove that angle B, that line segment B, not angle, is congruent to line segment C. And the reason is just going to follow from the transitive law. Statement and reasons. Statement 1 is line segment A is congruent to line segment B. If you want to list them separately, line segment A is also congruent to line segment C. Then number 3, line segment B is congruent to line segment C. Of course, 1 and 2, they would both be the reasons would be given. For number 3, if two line segments are congruent to a third line segment, so B and C are the two line segments that are congruent to a third line segment. The third line segment is A. Then the two line segments, in this case B and C, are congruent. That's called the transitive law. You can even use the transitive law in a different way. I could have labeled the earlier triangle AB, the last triangle is A, B, and C. And I want to say this is, here's the given. Line segment AB is congruent to line segment BC. That is, this length and that length, they're equal. In turn, line segment BC is congruent, say, to AC. That is, BC and AC are the same length. Well, AB and AC, line segment AB and line segment AC, they are both congruent to BC. AB is congruent to BC, and AC is congruent to BC. And of course, you're going to be asked to prove that AB is congruent to AC. Okay, so there's nothing really new here. Statement, reasons. First statement is the given. Whether you write them down or as just statement number 1 or write them down as statement 1, 2, and 3, doesn't matter. You write down the statements. And then the next thing is you can say that AB is congruent to AC immediately. If two line segments, namely the circled ones, AB and AC, if two line segments are congruent to a third line segment, namely BC, then the two line segments are congruent. In fact, since all three line segments are congruent, you have an equilateral triangle. Now, this section was entitled Substitution and Transitive. Well, let's talk about our substitution. Suppose that you were told that angle A is 2x plus 1 and angle B, let me draw the triangle. Angle B is, I want to make one change, please. Okay, fine. Angle B is 2x minus 5. And here's the given and what you're being asked to prove. You're given that angle A and angle B, they're congruent. And you're being asked to prove, no. You're being asked to find the measure of angle A. or the measure of angle B. After all, they're equal. And how you would do this is you would say, well, angle A and angle B, they're equal. I like to bring the x's to the side that has more of them, has more x's. That way you'll never end up with a negative number of x's. The left side of the equal sign has 2 x's, the right side has 3. Now bring the x's to the right side. I'm going to get rid of the 2 x's on the left side. I'm going to bring them to the other side. And since I'm bringing in all the x's to the right-hand side, it's reasonable I'm bringing the numbers to the other side, namely the left side. So let's get rid of the negative 5 on the right side and put plus 5 on the left side. Okay. Make sure this equal sign is valid. And of course it is. Negative 2x plus 5 is definitely equal to negative 2x plus 5. Okay, on the left side you just have 6. On the right side, 3 x's take away 2 x's is 1x. If you are fortunate enough to have 3 x's and somebody takes away 2 of them, you have 1x left. So x is 6. So if you want to know the measure of angle A, you know it's twice x and then add 1. You multiply x by 2, then you add 1. X is really 6 though. 2 times 6 is 12. You add 1, you get 13. 13 degrees, of course. And if you wanted to check, remember, there was something special about x equaling 6. It made angle A and angle B the same. So the measure of angle B should also be 13. It's 3 times x, which is 6, that's 18, minus 5. 18 minus 5 is 13 degrees. So it wasn't a hard check. So 6 degrees is x equaling 6, or 6 degrees actually, is the only value for x that will make this angle and that angle equal to one another. So that's what substitution means. Suppose you had this problem. Let's see, maybe we draw it like this. You have angle 1, angle 2, and angle 3. And you're told, let's even call this 1, okay? Actually, let's not. So let's go erase. All right, so here's the given. Here's the given. Angle 1 and angle 3, they're the same. So it doesn't matter, it's just a picture, but how am I going to do this? I want them to look more like the same. Well, let's just, so the picture doesn't live up to what I'm suggesting. All right, so let's change it this way. I'm sorry. Angle 2 and angle 3 are congruent. That's more realistic. Okay. And you're being asked to prove that angle 1 and angle 3 are supplementary angles. That is, they add up to 180. Okay, so let's do statement and proof. Statement and reason. The first statement is they're given. Angle 2 and angle 3 are congruent. Reason, they're given. It's given. R for reason. Okay. Now, angle 1 and angle 2 are supplementary. Remember, a straight angle is 180 degrees. Whether you put in another line or not, that angle is 180 degrees. And if it's 180 degrees, the supplement by definition. Angle 1 and angle 2 form a straight line. Okay. Now, I'm going to say that angle 1 and angle 3 are supplementary. And if you look at statement 2 and statement 3, word for word, character for character, the only difference is angle 2 and angle 3. But I can interchange them because they're congruent. You can replace an angle with its congruent, with a congruent angle. It's like you can replace equals for equals. If you come to know that x is equal to y, and somebody says that y is equal to z plus 4, you can say instead of y, x is z plus 4, because x and y are the same. These two horizontal lines, they have many, many meanings. It can say whenever you see x, you can put y, or anywhere you see y, you can put x. Same thing for congruent. It's just another way of saying that two angles are equal. For I'm a believer that they should use the equal symbol, not congruent symbol. Suppose you have this triangle. It's labeled A, B, C, D, E, and F. Angle C. And you are given the following. You say are given that BC plus BE is equal to AD. BC plus BE, this is the whole top, AD. And you're also given that BE is equal to EF. BE and EF are the same. So, you want to prove, instead of BE, you can put EF. You want to prove that BC plus EF is equal to AD. Now, to do this, you didn't even need a diagram. You didn't even need a diagram. Because this is given, and you know that instead of BE, you can write BF. BF. And you get exactly what it says on the bottom. So it's just substitution. 1. BC plus BF is AD. 2. BE is equal to EF. 3. BC plus EF is AD. The first two, of course, the reasons will be given. Number 3, substitution rule. You can replace equals with equals. You may replace equals with equals. You can replace EF. Let me say it differently. You can replace BF with EF. And of course, there's a typo here. It should say, sorry. The typo was on the given, the first given. BC plus BE equals AD. I just replaced one thing with it, with something that it equals. BE, I replaced it with EF. Okay, this finishes the section on substitution and the transitive law, or properties. Laws and properties, they're pretty much interchangeable in mathematics.